John started a business in which he earned $1 on the first day, $4 on the second day, $7 on the third day, $10 on the fourth day, and so on. What is his earning on day 1001? We can solve this problem by using simple math concepts. Let me explain the solution now in detail. According to the question, John started a business in which he earned $1 on the first day, $4 on the second day, $7 on the third day, $10 on the fourth day, and so on. The thing that is unique about the question is that each day his earnings increased by 3. The pattern looks like an arithmetic progression. Hence, the earning each day are in arithmetic progression where each term has a common difference, that is, difference in each consecutive term is constant. An arithmetic progression is basically a sequence of numbers such that the difference of any two successive members is a constant. For example, the sequence 1, 2, 3, 4, etc. is an arithmetic progression with common difference 1. Similarly, the sequence 3, 5, 7, 9, 11 is also an arithmetic progression with common difference 2. If the sum is S, the sum S of the first n numbers of an arithmetic progression is calculated by the formula S equals n into 2a plus n minus 1 into d divided by 2, where a is the first term in the sequence, d is the common difference between terms, and n is the nth term in the sequence. We use this formula to find the solution for this problem since the pattern looks like an arithmetic progression. In this sequence, a equals 1, which is a first term in the sequence, d equals 3, which is the common difference between terms, and n equals 1001, which is the nth term in the sequence. So now solve for a equals 1, d equals 3, n equals 1001. Substitute the value of a, d, and n in the formula n into 2a plus n minus 1 into d divided by 2. After substituting, equation becomes s equals 2 plus 3 into 1000 into 1001 divided by 2. After solving, equation becomes s equals 3002 into 1001 divided by 2. After solving this, s equals $1,502,501. Thus, total earning of John on day 1001 is $1,502,501. By using this simple math technique, you can solve this problem easily. A room has 2 exits. Door 1 empties the room in 3 minutes. Door 2 in 6 minutes. If both were open, how long would it take to empty the room? Let me repeat the problem. A room has 2 exits. Door 1 empties the room in 3 minutes. Door 2 in 6 minutes. If both were open, how long would it take to empty the room? Can you solve this problem in 10 seconds? In this video, I am going to teach you how to approach these kind of problems and solve it in less than 10 seconds. I will explain 2 ways of approaching the problem. Let's consider the first method. According to the problem, door 1 empties the room in 3 minutes, door 2 in 6 minutes. Since door 1 takes 3 minutes to empty the room, here is how the relationship works. In 3 minutes, room gets empty. So for 1 minute, 1/3 room will get empty. Thus, door 1 can empty 1/3 of the capacity in a minute. For door 2, in 6 minutes, room gets empty. So for 1 minute, 1/6 room will get empty. Therefore, in 1 minute, both doors together can empty 1/3 plus 1/6, which is equal to half of the capacity. If half of the room gets empty in 1 minute, then it is obvious that it would take 2 minutes to empty the room with both doors. By following these simple steps, you can achieve the solution in minimal time. The trick with these sort of questions is to calculate how much they can do in a set common period of time, add it together and then find total time. Let's look into the second approach. In this approach, we will use the concept of LCM to find the solution. I will show you how to solve such problems without touching a pen or paper. We know that from the question, door 1 empties the room in 3 minutes, door 2 empties the room in 6 minutes. Let the volume of the room be the LCM of 3 and 6, which is equal to 6 liters. Therefore, door 1 removes 2 liters each minute, while door 2 removes 1 liter every minute. Together, they remove 3 liters each minute. Thus, time taken to empty the room equals 6 by 3, which is equal to 2 minutes. Here 6 is the total capacity and 3 is the total liters removed each minute. Thus, answer to the problem is 2 minutes. You can use any of these methods to solve the problem in less than 10 seconds. Here the question is it possible to make 5 with only 2 2's using only elementary mathematical functions? Any mathematical function can be used, even roots is allowed to use. This can be achieved in numerous ways. Note that you are allowed to use only elementary mathematical operations and not advanced mathematical functions. I will explain two ways of achieving this, one through math way and the other through just logical way without using much math concepts. Through math way, we can achieve this by using math expression square root of 0.2 to the power minus 2. It is just take 0.2 and raise it to the power of minus 2 and then take the square root. Let's simplify the equation. 0.2 can be represented as 2 by 10. Now the expression becomes square root of 2 by 10 whole to the power of minus 2. And 2 by 10 whole to the power of minus 2 can be represented as 10 divided by 2 whole to the power of 2. Hence expression becomes square root of 10 divided by 2 whole to the power of 2. After solving this, we get square root of 25, which equals 5. This is the math way to find the solution. Now I will explain the logical way without using much math operations. Just consider the math expression square root of 22. So now mirror the second 2 to get the 25. This looks like square root of 25 and we know square root of 25 is 5. So this will work perfectly on digital display because 2 is the mirror of 5 exactly. So there are many correct answers to this question. I have explained two possible ways of finding the answer to this particular problem. Do comment your answer in the comment section. There are many complex ways where you can achieve the solution for this particular problem. I have explained the two simple ways how you can achieve the solution. In the addition given here, all digits have been replaced by letters. Equal letters represents equal digits and different letters represent different digits. Can you find the digits which represents letters and what does the complete addition looks like in digits? Let me explain the solution now. There are three most important points one must remember before beginning to solve these kind of math problems. Number 1. Since there are 4 numbers in each column, maximum sum possible using 4 digits is 36. That is by using 4 nines. And number 2, since the maximum number possible using 4 digits is 36, maximum remainder possible in each column is 3. Number 3. Maximum sum possible in each column is 39, that is after adding remainder to the maximum sum 36. Now we have to apply these three most important rules to find the value of each letter. Also, we must make a decision on how to start, whether to start from the right or left columns. Let's observe the problem carefully and see the answer. According to the answer, there is a repeated number which suggests that it is a good thing to start from the left columns. Here in this problem, A is repeated. Possible digits for A is 0, 1, 2, 3. Why? It is because we know that maximum sum possible using 4 digits is 39, including remainder. So A cannot be more than 4. We can eliminate 0 because 0 cannot be a digit to A. So now consider if A equals 1. If A equals 1, then AA is 1, 1. In the last column, letter A is repeated thrice. Sum of 3 A's will yield 3, and to get the value 11, sum of B and remainder must be 8. Now possible combinations that satisfy the value of 8 is 0, 8, 1, 7, 2, 6, 3, 5, where first digit is remainder and second digit is the value of B. Only two digits that satisfy the given addition is 2, 6. You can try other possibilities, it is not definitely going to satisfy the condition. Thus, the value of A is 1 and the value of B is 6. Now we have the value of A and the value of B. Now the whole calculation gets simplified. Now use the value of A and B in the right columns. Consider the first column. Value of rightmost column after substituting the values of A and B is 1 plus 1 plus 6 plus 1, which is equal to 9. Hence, value of H is 9. Now consider the next column. After substituting the value of A and B in the second column, the expression becomes 6 plus 1 plus 6 plus 1 equals to 14. Thus, the value of D is 4 and 1 is the carry forward to the next column. For the next column, expression becomes 1 plus C plus 1 plus 6 equals X6. Expression includes remainder and X will be the remainder for the next column. After solving, expression becomes 9 plus C equals X6. The only number which satisfies for C for this expression is 7 and X will be 1, and that is the carry forward for the next column. Now get into the next column. Now we have the value of A, we have the value of B and the value of C. Now apply the value of A, B, C for the next column. Now the expression becomes 1 plus 7 plus 4 plus E plus 4 equals XG. There are multiple digits which satisfies for the value of E. Let's consider the least number which satisfies the expression. The least number would be 2. Sum will be 18. Thus value of G is 8 and the remainder will be 1. Now after substituting the value of B in the next column, the value of F will be 5. So the complete addition looks like this. This is hard math puzzle and requires a systematic approach to find the solution. If you follow these simple steps, whichever I have explained in this video, will definitely help you to solve these kind of problems in a minimum time. A farmer has many goats and chickens. There are total 20 heads and 76 legs. How many goats and how many chickens does the farmer has? This is a math puzzle. Correct method to solve this kind of puzzle is through creating equations. As per the puzzle, we know total number of heads are 20, total number of legs are 76. Let the number of goats be X and let the number of chickens be Y. So each of them have one head and each chicken has 2 legs, whereas each goat have 4 legs. So total number of heads is heads of goats plus heads of chickens, which is equal to 20. So now the equation becomes X plus Y equals 20, where X is number of goats and Y is number of chickens. Also we know that from the puzzle, total number of legs is legs of goats plus legs of chickens, which is equal to 76. Now equation becomes 4 into X plus 2 into Y, which is equal to 76. 4X is because X represents the goats and each goat have 4 legs. That's why it is 4X. 2Y is because the Y represents the number of chickens and each chicken has 2 legs. After simplifying, equation becomes 2X plus Y equals 38 and call this equation 2. Now solve the equation 192 to find the value of x and y. Subtract equation 1 from equation 2. This will result in 2x plus y minus x minus y equals 38 minus 20. After solving this equation, the value of x is 18. Substitute the value of x in equation 1, value of y becomes 2. Thus x equals 18 and y equals 2, which means number of goats equals 18, number of chickens equals 2. By following these simple steps, you can find the solution to these kind of puzzles in minimal time. The problem statement is how many 5-digit prime numbers can be obtained by using all the digits 1, 2, 3, 4 and 5 without repetition of digits. So you are given 4 options. They are 0, 1, 9 and 10. So let me elaborate the problem. So first of all, it is important to understand what are prime numbers. So prime numbers is a number that is divisible only by itself and 1. For example, 2, 3, 5, 7, 11, they are all prime numbers because it is divisible by 1 and itself. So the digits 1 to 5 can be rearranged into many distinct 5-digit numbers. So your task is to find all the prime numbers formed using the digits 1 to 5. Basically, you need a trick to solve this complex problem. So it is not easy to find the solution to this problem unless you know the trick to find those numbers which are prime numbers. The trick which we can use here is divisibility rules. The most important rule which comes handy here is divisibility rule to find the number is divisible by 3 or not. The rule states that a number is divisible by 3 only if the sum of all digits of a number is divisible by 3. For example, 123 is divisible by 3 because sum of all the digits in the number is 1 plus 2 plus 3, which is equal to 6, and 6 is divisible by 3, hence 123 is also divisible by 3. Take another example 1, 2, 3, 4, and this is not divisible by 3 because sum of all the digits in the number 1, 2, 3, 4 is 10, which is not divisible by 3. So this is an interesting rule. Regardless of number of digits in a given number, this rule works. We can utilize this rule to solve this problem. I will explain why this rule is important. So what we can do now is add all the numbers from 1 to 5. It is because regardless of arrangement of numbers in any combinations, their sum remains constant. Sum of all numbers from 1 to 5 is 15, and sum of the digits in number 15 results in 6, that is 1 plus 5 equals 6. Since 6 is divisible by 3, regardless of the arrangement of 5 digits from 1 to 5, in whatever way, that number will be divisible by 3. Thus, there are more than 2 factors for any arrangement of digits. If the number has more than 2 factors, then the number is not a prime number. So thus, answer to this problem is none. None of the numbers are prime when the digits 1 to 5 rearranged in any distinct 5-digit numbers. So to summarize, the sum of numbers from 1 to 5 is 15 and therefore can be divisible by 3. Since the number of factors is more than 2, none of the numbers are prime. Hope you understood the solution. If you have not understood the solution, please watch it again and let me know if you have any questions. I will try to address as soon as possible. Let XYZ be a 3-digit number where x plus y plus z is not a multiple of 3. Then XYZ plus YZX plus ZXY is not divisible by which of the following option? The options are 3, 9, 37, x plus y plus z. Let me solve this problem step by step. To solve this problem, one must know to represent generalized form of a 3-digit number. The general form of XYZ equals 100x plus 10y plus z. Similarly, the general form of YZX equals 100y plus 10z plus x. And the general form of zxy equals 100z plus 10x plus y. And call these equations as 1, 2 and 3. So now add all these three equations. Adding three equations we will get XYZ plus YZX plus ZXY equals 100x plus 10y plus z plus 100y plus 10z plus x plus 100z plus 10x plus y. After solving this equation, so the result is XYZ plus YZX plus ZXY equals 111x plus 111y plus 111z, and call this equation as 4. Now simplify the equation 4. We will get XYZ plus YZX plus ZXY equals 111 into x plus y plus z. Now it is clear that 111 is the common factor. So XYZ plus YZX plus ZXY is divisible by 111. Also, XYZ plus YZX plus ZXY will be divisible by factors of 111. From the above options, 3 and 37 are factors of 111, hence these two numbers are divisible by 111. And as we can see in the last expression, x plus y plus z is also a factor of 111 into x plus y plus z. So only number which is not divisible in the given option is 9. Hence the solution to this problem is 9. See, by following these simple steps, you can solve these kind of problem in less time. One page is torn from a booklet whose pages are numbered in the usual manner starting from the first page as 1. The sum of the numbers on the remaining pages is 195. The torn page contains which of the following numbers? Is it 5, 6 or 7, 8 or 9, 10 or 11, 12? The most important thing about solving this problem is not just finding the correct solution, but to find it in less time, because that's what it demands in most of the competitive exams. So I am going to teach you how to solve this problem in less time. First of all, it is important to know one of the most important formula to solve these kind of problems, that is sum of n natural numbers. The formula is important here because the pages in the book are marked in the form of natural numbers, that is 1, 2, 3, 4, etc. We know that the sum of all the numbers from 1 to n can be calculated by using the formula n into n plus 1 divided by 2, where n is the last number in the series. Remember, this formula is applicable for only positive natural numbers. For example, sum of first 10 natural numbers is calculated like this, that is 10 into 10 plus 1 divided by 2, which results in 55. In this case, n equals 10. Let's come back to the problem. Since page numbers are represented in the form of natural number series, without doubt, sum of all page numbers including torn page must be greater than 195. Now the task is to substitute for value of n till we get the number which is greater than 195. Now pick some random numbers. For example, first consider n equals 15. Sum of first 15 natural numbers is 15 into 16 divided by 2. This is after applying the formula n into n plus 1 divided by 2, which is 120 after solving. Since 120 is less than 195, we have to choose the other number which is coming close to 195 and it should be greater. So now consider n equals 20, which will result in 20 into 21 divided by 2. This equals to 210. This can be a right number which we are looking for, because for n equals 19, sum results in 190, which is less than 195. Hence 19 must be rejected. Thus number of pages in the book is 20, and now the task is to find the torn page. So now we need to subtract 195 from 210, which results in 15. So what are the two consecutive numbers those sum will result in 15? They are nothing but 7 and 8. Thus answer to the problem is 7 and 8. This is the approach one must follow to find the solution to these kind of problems. So I will show you one more problem which requires similar logic. So the question reads like this. We are given a series of numbers which contains integers from 1 to 50, including both 1 and 50. However, the numbers are in a jumbled form, that is, they are not arranged in increasing or decreasing order, and there is one integer missing. You have to identify the missing integer. How will you find? Let me explain the solution. We know that the sum of all the numbers from 1 to n can be calculated by using the formula n into n plus 1 divided by 2, where n is the last number in the series. In this case, n is 50. So therefore, sum of all the numbers from 1 to 50 is 50 into 51 divided by 2. After solving, sum of all numbers from 1 to 50 is 1275. Therefore, all we need to do is to sum all the integers present in the given series and subtract the sum from 1275. So this is the same procedure that we followed for the previous problem as well. So the difference between 1275 and this sum would give us the missing integer. Because 1275 is sum of natural numbers from 1 to 50 and this number is sum of natural numbers from 1 to 50 without including missing number. Hence, subtracting the sum of given series from 1275 will fetch the missing number. So this is the logic to be used to find the missing number in the given series, provided that the series is positive natural numbers. And this is the logic to be applied in order to solve these kind of problems. If 29 minus 1 equals 30, 9 minus 1 equals 10, 14 minus 1 equals 15, based on this logic, can you find the value of 11 minus 1? In order to solve this problem, one should have the knowledge on representation of numbers in Roman numerals. Roman numerals are written using 7 different letters. They are I, V, X, L, C, D and M. They represent the numbers 1, 5, 10, 50, 100, 500 and 1000. We use these 7 letters to make up thousands of others. For example, the Roman numeral for 2 is written as I. The number 12 is written as XII, which is just X plus II. If you take this a step further, the number 27 is written as XXVII, which when broken down looks like XX, which is 20, plus V, which is 5, plus II, which is 2. Summing all will result in 27. The Roman numeral for 3 is written as III, but 4 is not written in the same way. Instead, the subtractive principle is used. The number 4 is written as IV. Here we have I before V, and because the smaller number is before the larger number, we know that we have to subtract here, making IV 4. The same principle applies to the number 9, which is written as IX. Let's use the same principle to solve this math puzzle. In the first equation, Roman equivalent of 29 is XXIX, and Roman equivalent of 1 is I, and Roman equivalent of 30 is XXX. If you observe carefully here, actual subtraction is not performed. Instead, Roman numeral I, which is a second numeral, is removed from first numeral, which results in XXX, which is RHS of the equation. Similarly, in the second equation, 9 is represented as IX and 10 is represented as X. Here again, numeral I, which is a second numeral, is removed from the first numeral, which results in X, which is RHS of the equation. And finally, in the third equation, 14 is represented as XIV and 15 is represented as XV. Here again, numeral I, which is a second numeral, is removed from first numeral, which results in XV, which is RHS of the equation. So now apply the same logic for the final equation. Roman equivalent of 11 is XI. Now remove I from the numeral, which results in X. Thus the solution for this puzzle is X, and its equivalent decimal representation is 10. Thus the answer to this puzzle is 10. If you have the knowledge how to represent the numbers in Roman numerals, then solving this puzzle is very simple. Let's see if you can solve this one. Watch the diagram very carefully, use the clues available in the diagram, and now answer what is the height of the table in centimeters. Pause the video and give a try before checking the solution, and do not forget to comment the answer in the comment section. Let's check the solution now. Whenever you come across such kind of problems, without hesitation, try to solve it systematically instead of following some blind methods. The most logical way of solving this problem is by creating the equations. If you observe the diagram, there are three important components. They are table, cat, and tortoise. Let's assume that height of the table is T, height of cat is C, and height of tortoise is R. Let's write down the equations by observing the diagram. As per the first diagram, total height of the table along with cat excluding the tortoise height can be written as T plus C minus R equals 170 centimeters. So here T is the height of the table and C is the height of the cat and R is the height of the tortoise. Since the height of the tortoise is not included in the diagram, we are excluding it by subtracting R, which is resulting in 170 centimeters. As per the second diagram, total height of the table along with the tortoise excluding the cat height can be written as T plus R minus C is equal to 130 centimeters. If you observe it carefully, so the height includes the table and the tortoise excluding the height of the cat. Hence the equation becomes like this. Now we have formed two equations. When there are two equations, then the job becomes simple. Let's solve these equations by adding both the equations, which results in T plus T, which is 2T, plus C minus R plus R minus C equals to 170 plus 130 centimeters. In the equation, we can cancel plus R minus R plus C minus C. Finally, it results in 2T is equal to 300 centimeters and finally T is equal to 150 centimeters. This is the solution for the problem. The height of the table is 150 centimeters. By following these simple steps, we can solve the problem in minimum time. Most of the time what happens is the people try to solve some blind method without even using the equations. See, sometimes it may work, but most of the times you fail to answer with a given time. So I always recommend to all my students and the candidates to go with a systematic approach instead of following some blind approach. A man walks into a store and steals a $100 bill from the register without the owner's knowledge. He then buys $70 worth of goods using the $100 bill and the owner gives $30 in change. How much money did the owner lose? Is it $30, $70, $100, $130, $170 or $200? Let me repeat the riddle. A man walks into a store and steals a $100 bill from the register without the owner's knowledge. He then buys $70 worth of goods using the $100 bill and the owner gives $30 in change. How much money did the owner lose at the end? So the options are $30, $70, $100, $130, $170 or $200. This is a math riddle and it's a tricky one. You will probably need to sit for a while with a pen and paper to work it out. Feel free to pause the video and try yourself before checking the solution. Do subscribe, like and share the video. Let's check the solution now. The answer to this riddle is the owner lost $100. Let me explain this in detail. The riddle seems really confusing, but if you break the question down step by step, it's really not that difficult. The riddle starts with the man steals $100 from the register. He then gives the $100 back to the owner when he pays for the goods. Now the $100 which is stolen is with the owner. At this point, owner did not lose any money. But the owner has then lost $70 worth of goods. At this point of time, owner encountered a loss of $70. Then the owner also loses $30 when he gives the man his change. So total loss encountered by the owner is $70 worth of goods plus $30 change, which is equal to $100. Thus the answer to this riddle is $100. Even though the sentences used in the riddle confuse you in achieving the correct answer, but if you analyze the riddle step by step, then the whole analysis becomes simple. A riddle states that there are 7 sisters standing around the kitchen table. Each one has 7 backpacks. In each backpack, there are 7 large cats. For every large cat, there are 7 small cats. How many legs are there in the room? Word problems can be difficult because they introduce another layer between us and the mathematical steps that we shall need to solve the problem. Breaking the problem into pieces and making sure that we properly combine all of those pieces in the end can help with this sort of problem. For example, if part of the problem tells us that 7 people each have 7 objects, we can start by interpreting this as a multiplication problem. In order to solve this riddle, we must start from the top. According to the riddle, there are 7 sisters around the table, thus there are 7 girls. These 7 girls have 7 backpacks, therefore there are 49 backpacks. In each backpack, there are 7 big cats, therefore total number of big cats is 49 into 7, which is equal to 343. And for each big cat, there are 7 small cats, therefore total number of small cats is 343 into 7, which is equal to 2401 small cats. Now we must find out how many legs are in the room. Assuming that each girl has 2 legs and each cat has 4 legs, total number of legs will be 7 into 2 plus 343 into 4, this is for big cats, plus 2401 into 4, this is for small cats. After solving this, total number of legs will be 10,990 legs. Hence, total number of legs will be 10,990 legs. By following these simple steps, you can solve these kind of algebra math problems in a very simple way. That's all for this video. Let me know if you have any questions. I will try to address as soon as possible. Thanks for watching and thank you for your support.